Let's integrate 1 all over sine theta raised to 4 plus cosine theta raised to 4 minus 1. Now here, you may be thinking that's actually long. It's actually, yeah, you do have a point. It's actually long. And yeah, we have to do something about this. Like we have to manipulate this problem before we integrate it directly, right? Before we proceed, I actually posted a solution and an explanation on how to solve this problem. All right, let me just switch my presentation here. That's it. First, I posted it in Instagram. All right, hold on. That's it. All right. I posted it as a reel. I couldn't post it as a post version. Like basically, if you have multiple photos and you're just gonna swipe right or swipe left, I can't do that because once I did that, it will only capture the given ratio. So that means it doesn't capture the whole picture. So sadly, I can't. But I gave a reel, so you can just simply post it and you can just read my explanation. Other than that, I posted on my Facebook page, which is here. All right, this one. So I had like yeah, this picture and then yeah, swipe left. No, swipe right, I'm sorry. Yeah, so yeah, that's it. No, wait, swipe left. Yeah, right. Yeah, you just swipe left and you can read the explanations and so on and so forth. And lastly, I posted it in my Instagram. All right. Instagram, TikTok. All right. Wait, hold on. Yeah, that's it. Let me just bring down my camera here. Someone commented actually this simple math. Yeah, actually, yeah, quotation, simple math. But yeah, you can go to my description and you will see the link of my TikTok account, Facebook page, and Instagram. All right, there you will see these posts. All right, these posts, I mean. All right. So that will be all. Let's now proceed in, solving it, right? How will I explain it to you, visually speaking? And of course, since now we are in YouTube, so how will I explain it as if I'm making a video out of it? Okay, so here, how to solve this one? You see, this one, this sine theta raised to 4 plus cosine theta raised to 4, it actually it actually reminds me of a Pythagorean identity in trigonometry formula. Because this reminds me of sine squared theta plus cosine squared theta is equal to 1. So if you get the sum of sine squared theta and cosine squared theta, you will immediately get 1. Yeah. But here's the problem, right? The problem there is that if we have sine theta raised to 4 plus cosine theta raised to 4, it doesn't equate to 1. It doesn't equate to 1. You may be thinking, oh, maybe, maybe if I have, like, let me change the exponent. Okay, if I have sine theta raised to 4, cosine theta raised to 4, that means I have 1 squared. No, that doesn't work that way, right? It doesn't. It may look similar, but that doesn't mean they are the same, right? However, there's one thing that I would like to share though, and is that you see, if I am going to have a squared binomial where the terms are sine squared theta plus cosine squared theta, like if I have this and expand it, then I will be having sine theta raised to 4 plus 2 sine squared theta cosine squared theta plus cosine theta raised to 4. All right. So if I have, not only sine theta raised to 4 and cosine theta raised to 4, but also 2 sine squared theta cosine squared theta, I will be able to convert it into this. So I need these three parts for me to convert it into the square of sine squared theta plus cosine squared theta. The question is how? Like, how are we going to input 2 sine squared cosine squared theta in the denominator? You can just simply put 2 sine squared cosine squared theta there, but you have to include its negative sign. I mean, negative version. Let me give an example, okay? For you to understand what I mean. I have a simple equation. Let's just say I have A plus B, okay? I want to put C here, okay? I want to put letter C. If I'm going to do that, I'll be having A plus B plus C minus C. We have to do like that, okay? Don't just simply put the one we're looking for, but also put the negative version as well. Why? So that it will still satisfy the equation. Let me tell you. Okay, let's just say I have an equation. Let's just say I have x is equal to y. Okay, for example. And let's just say I want to put c, like on the x. Okay. If I'm gonna put c on the x, okay, like plus c to be particular, you will do the same thing on the right. So you will have x plus c is equal to y plus c. All right. So basically, what you do to the left is also what you will do on the right. Okay. So another example, if I'm going to put negative 1 on y aside from plus c, then I will do the same thing to the x. So I will have x plus c minus 1 is equal to y plus c minus 1. All right. So what you do to the left is what you will also do to the right. Now, here's the thing. You see, how about in one side? Okay, like, um, right? What you do to the left is also what you'll do on the right, right? But by chance, like by chance, how about like what if we try to input something on one side, not on both sides? We can. Okay, we can. Okay. We can do that. Okay. Let me erase this part. Okay. Let's focus on x plus c and is equal to y plus c. Okay. Like what if you want to put c only on one side? You can, but you need to include the negative sign. So for example, I want my C here on the left. I can. Okay, I can put all C's on the left. Okay, just transpose the plus C or from the right side to the left. So I will have x plus C minus y minus C is equal to y. Okay, if you only want one side only, okay, that's it. If you want only one side, okay, no problem. But you have to put its negative version as well. Okay. Plus, it would make sense because take a look. The original equation is x is equal to y. C minus c, 0. So x plus 0 is what? X. So you have x is equal to y. Point being, we still need to satisfy the equation. We have to make it the same. Okay? So if you want to put one thing, just one thing you like to put, okay, on a one side of the equation, then don't forget to include its negative sign. So just like here, if I want to put C here, also include the negative sign. Therefore, okay, therefore, if if we want to have 2 sine squared cosine squared theta here, okay, here, so that we can convert it into the square of sine squared theta plus cosine squared theta, then, oh, wait, hold on. Wait, what happened? Wait, hold on. All right, anyway, then we must put the negative version as well. So as a result, okay, let me just copy the denominator here. Okay, so as a result, I'll be having plus 2 sine squared theta cosine squared theta minus 2 sine squared theta cosine squared theta. That is what I'm going to do. Okay, that's it. Okay, now since I have 2 sine squared theta, cosine squared theta, I can group them up with these two. So the results would be just sine theta raised to 4 plus 2 sine squared theta cosine squared theta plus cosine theta raised to 4. Okay? Then let me just copy the other terms. Okay, minus 1 minus 2 sine squared theta cosine squared theta. So in this case, I can now, wait, hold on, let me just copy the other terms first. Okay. In this case, I can now convert these, sorry, this group into the square of sine squared theta plus cosine squared theta. Okay. So we will have the square of sine squared theta plus cosine squared theta. Okay, squared. That's it. Then let me just copy the other terms. Okay. Then remember earlier that sine squared theta, cosine squared theta. Remember, okay? I already wrote this earlier, but just to have a short recall, sine squared theta plus cosine squared theta is simply 1. Okay, just equal to 1. So I can now have 1 squared, wait, 1 squared. Then let me just copy the other terms. Okay, 1 squared minus 1 minus 2 sine squared cosine squared theta. That's it. Okay. Now we can simplify this even more because you see 1 squared theta is just the same as 1. And combine it with minus 1, what will happen? It's just 0. So 1 minus 1 is 0. Okay. So we will have 0 minus 2 sine squared theta cosine squared theta. We will have negative 2 sine squared theta cosine squared theta. That's it. Right? It seems like it's already simplified. So can we get the integral? Not yet. Because here, we still can't integrate this one properly. All right? Or directly, I mean. So what's the best way? Or rather, what are the ways that we're going to do for us to get the integral? So in here, you see, it again reminds me of a trigonometric formula. And what formula would that be if you're going to ask me? That would be the double angle identity. All right? Because this one is similar as sine of 2 theta is equal to 2 times sine theta cosine theta. You see, they are similar because you see, they have 2, they have sine, they have cosine, but they are different. Different because we have a negative 2 and the sine cosine have squared, right? They have squared. So that means we can just simply convert this into sine of 2 theta. We can't, right? If we have 2 sine theta cosine theta, we can convert it immediately to sine of 2 theta, right? In fact, that is the next step. We have to convert it into sine of 2 theta. But how though? Because we have squared, right? So here's the thing. First and foremost, okay, what I'm going to do here, let's focus here, okay? Let's focus here. What I'm going to do here is, what if I square both sides? Okay, what if I'm gonna do that? Like, imagine both sides, the left has a squared, and on the right side, it also has a squared exponent, right? Just imagine. Here we will have sine squared of 2 theta is equal to 4 times sine squared theta times cosine squared theta. So you see, here's the thing, here's the thing. You see, if we're going to go back to the problem here, if I have 4 instead of negative 2, I can convert this into sine squared of 2 theta directly. okay, directly. Problem is we have -2 instead. So how are we able to find sine squared of 2 theta in this case? First, we're going to factor out -2 on the denominator, right? So if we're going to factor out -2 on the denominator, we will have 1 all over -2 times the integral of sine squared theta cosine squared theta. That's it. Okay. Then you see this 1 all over -2? I can simply bring out the negative sign and put it beside the fraction. So I will have -1/2 instead. Okay, it's valid, okay? Like if one of the side of the fraction, whether one is negative or not, just simply bring out the negative sign outside. Okay, so I have -2, bring out the negative sign. So I will have -1/2. Okay, much better. Okay, now let's go back. Okay, we need 4 besides sine squared theta cosine squared theta so that we can convert it immediately to sine squared of 2 theta. So what I'm going to do here is I'm going to put what? 4 all over 4 besides sine squared theta cosine squared theta. 4 all over 4. Then let me just copy here. Sine squared theta cosine squared theta. Now, why? If you're asking me like why I put 4 all over 4. 4 all over 4 beside sine squared theta cosine squared theta. You see, first, let's relate it to a identity property of multiplication. All right. So here in identity property, let me put it here. In identity property of multiplication or IPM, or for me, I usually say it identity property of equality of multiplication because there are many forms there are many forms of identity property of equality that based on a given operation, but let's focus here on IPM because we're talking about multiplication. Basically, if I have A, it's just the same as 1 times A. Basically, in any term, it has a factor of 1. Okay? For example, I have 2. I can just have 1 times 2. 4. Instead of 2 times 2, I can have 1 times 4. X. X is just the same as 1 times x. 3x squared is just the same as 1 times 3x squared. All right? So last example, let's just say I have sine x. This is just the same as 1 times sine x. So therefore, if I have, wait, did I copy it here? Yeah. Therefore, if I have sine squared theta cosine squared theta, this is just the same as 1 times sine squared theta cosine squared theta. But this is still not yet the whole reason why we have 4 all over 4. Okay, so why we have 4 all over 4 besides sine squared theta cosine squared theta? Here's the thing. Okay, you see, you will able to get 1 if you have a fraction where the denominator and the numerator are the same. Like for example, a all over a. Numerator and denominator is the same. So for example, I can have 1 as 2 all over 2. I can have 1 as x all over x. I can have 1 as, let's just say, x minus 1 all over x minus 1. Okay? So, meaning, okay, let's go back. I wanted to have 4 besides sine squared cosine squared theta, right? I wanted to have 4 because we can convert 4 sine squared theta cosine squared theta into sine squared of 2 theta, right? So if I wanted to have 4, then I can make 1 as 4 all over 4. I can make it as 4 all over 4. So therefore, instead of just 1 times sine squared theta cosine squared theta, I can just simply change it into 4 all over 4 sine squared theta cosine squared theta. That's it, right? And that is what and that is what I did here. That's it. Then we now multiply together the denominators. So you will get 4 sine squared theta cosine squared theta all over 4. Okay, then copy the numerator. And that's it. Then we can now convert. Okay, convert 4 sine squared theta cosine squared theta into sine squared of 2 theta all over 4. That's it. Then let's now simplify this whole problem because this looks complicated. We have a complicated fraction. So in this case, I will just have negative 1/2 times the integral of, copy the numerator, 1 times the denominator, but the positions were switched. So you will have 4 times sine squared of 2 theta. So in this case, this is just negative 1/2 times the integral of 4 all over sine squared of 2 theta d theta. That's it. Okay, now we're not done yet because here we can't integrate it yet. We can't. Okay, but uh, the thing that we're going to do here for us to make it integrable is easy because you see, okay, if we're going to recall an identity in trigonometry, which I do believe it's reciprocal identity, cosecant theta is just the same as 1 all over sine theta. So if I have cosecant of 2x, I can have 1 all over sine of 2x. That means if I have sine squared, oh, sorry, that's wrong. If I have cosecant squared of 2x, then I will have 1 all over sine squared of 2x. So if I have 1 all over sine squared of 2x, I can make it into cosecant squared of 2x. Okay, that's it. So in this case, I'll be having negative 1/2. Okay, let me just bring down the 4. 4 times 1 all over sine squared of 2 theta times d theta. Okay, so in this case, we will have 4 times cosecant of, as cosecant squared of 2 theta. That's it. Then I can bring out my 4 outside. Okay, it's like I factor out 4. So I will have negative 1/2 times 4 times the integral of cosecant squared of 2 theta. Okay? So here, negative 1/2 times 4 is negative 2. So here I will have this one. Now, we already simplified the problem. We went from this very long type of problem into its simplified problem, which is this one. Now, can we now integrate it? Not yet. Not yet. Why? Because you see, there exists a composite function. Basically, there is a function inside of a trigonometric function. Because inside of a trigonometric function is another function, 2 theta. Here, we can safely assume that this is an algebraic function. So in that case, what are we going to do if we have a composite functions to integrate? Here, we will use U substitution. Okay. So here, let U as 2 theta. Then we will get the derivative of U with respect to theta I will have 2 d theta. Okay? Then, I'm going to find d theta in this equation. So I'm going to divide both sides by 2. I will have du all over 2 as d theta. So what I have as my u and as my d theta, I am going to substitute it here. All right. So therefore, I have um, negative 2 times the integral of cosecant squared of 2 theta as u, so u, times d theta as du all over 2. Okay. I can factor out the 2 here, the denominator 2 outside, so I will have negative 2 times 1 half times the integral of cosecant squared u. Negative 2 times 1 half is negative 1. Okay, or just simply put negative sign. That's already enough. So what's left is we have negative integral of cosecant squared u. And here, we can now integrate it because you see the integral of cosecant squared x is basically negative cotangent x. So therefore, I will have negative quantity negative cotangent u plus c. So negative times negative will give you positive. So you will have positive cotangent u plus c. But we're not done yet. Why? Just remember, okay? But we substitute u as 2 theta, right? So we will bring back the 2 theta. So here we have the tangent of 2, wait, hold on. So we have the cotangent of 2 theta plus c. And there we go. That is your final answer. Yeah, that's your final answer, right? So that's it, guys.